Last time we talked about mutually exclusive and complementary events, and today we're going to tackle one of the probably hardest parts of probability, which is dependent events. So this is where we dive into conditional probability, and that deals with the idea of what is the probability that something occurs given that something else has already occurred. So let's just start off with a question, and this question says, okay, we have a box. We've got 7 red balls, 3 blue balls, and 6 green balls in our box. Now, let's say, uh, pretend I take out a ball at random, and it just so happens to be one of these red balls. So I'm going to take it out of the box. Now, I'm going to leave it out, and I'm going to now take another ball at random from the remaining balls. What is the probability that I pick out another red ball? Now this is pretty easy question to answer. We simply know that, okay, I have 6 red balls left, and in total there would be 15 balls left. And so the probability, let's say A is, I pull a red ball on the second pull. Then the probability that A occurs, this is where we run into some neat notation. We can't just say probability of A occurring. We need to consider that, okay, if I just say probability of A, this doesn't take into consideration the fact that the first ball that I picked out was red. What if the first ball I picked out just happened to be green instead? Then P of A would be different. It would be 7. There'd be 7 red balls left instead of 6. And so P of A does not work here. We're forced to use a different kind of notation. And this is where we see the straight line being used. So just like the other weird things, we've got and, or, this was not. Think about this. This one's not really a logical connector, but just think of it as given. So the probability of A given that some other event B, let's call it B, occurs. And so what would event B be? Event B is I pull a red ball on the first pull. Because that's what happened. This occurring is event B. So now this makes sense. The probability that I pull a red ball on the second pull, given that I've already pulled one on the first pull, now we can calculate this. We know that this ball is gone. We have 6 over 15. Cool. But what was the probability that this whole series of events happened, including the fact that I pulled this first ball out? Well, to find that, let's multiply the probability that B occurred. Right? What is the probability that the first pull happened to be a red ball? And we're going to multiply it by the probability that the second draw was also a red ball. So what's P of B here? It would be 7 over 16. Since there are 7 red balls and 16 total balls, we're going to multiply it by our answer here, which is going to be times 6 over 15. So 7 times 6 is 42. 15 times 16 is 15 times 15 plus 15 is going to be 240. And this is going to simplify to divide by 6, 7 over 40. So this is the probability that event that first I pull out a red ball, and my second ball is also a red ball. So the kind of difficulty in this question comes from the idea that event A is conditional. The probability of A depends on what happened before A. So it's not independent. When you're dealing with conditional probability, you're dealing with dependent events. Events that will change their probability based on stuff that happens before the event occurs. And that's when you need to use this kind of given notation, and you need to use different formulas. Anyways, that's basically all of probability. We can go over sets later, but sets are pretty easy. So yeah, join us next time.